This is part one of section 7.1, finding the area between two curves. Here's the first example, composite. I'll go ahead and set this up and I'll explain what's going on before we actually dive into to solving it. So I went ahead and graphed the curve. I'll zoom in so you can pause it and sketch a very accurate and detailed graph. So the area in question is the area between the curve, which is kind of this little leaf looking piece. So I'm looking for this region in between them, and it starts at 0 and it goes all the way to 1. So the basic approach is, since you have two curves, is I'm going to first find the area of the big piece, the big curves from 0 to 1. So I'm going to go all the way across to 1. But notice I have this extra kind of wedge looking piece that I don't need. So what I'm going to do is I'm going to find that area and then subtract it. I kind of think of it, if I find the entire piece and then I take away this little extra wedge piece, what I would be left over with is the area that I'm looking for. So that's the main idea, is I find the entire area and then take away the bottom area, and that leaves me with the area that's in between. Alright, so here are the basic steps to finding the area between two curves. You first want to find the boundary of the region. So this basically just means you want to find where the region starts and when it ends. You want to identify next the top and the bottom functions. You want to figure out basically which is the region that's going to be on top and which is the bottom region you're going to be subtracting away. And then the last step is to integrate the top curve from the bottom curve. And then A and B are going to be where your region starts and ends. So A and B refer back to finding the region that it's bounded by. Okay, so back to this problem. Alright, so this region starts at 0 and it ends at 1. So my integral is going to be from 0 to 1. The top curve is going to be the upside down parabola. So that's going to be the 4x minus 2x squared. So it's going to be the integral of 4x minus 2x squared. So this integral would give me this entire piece, which is too much. So I need to subtract away the bottom wedge piece. So I'm going to subtract away the bottom, which is 2x squared dx. So this is basically the setup that I have now, is top curve minus the bottom curve. Now you have two options. You could either just integrate from here. You can simplify this integral and then integrate, which is what I'm going to do. So I'm going to simplify this to be 4x minus 2x squared minus 2x squared, which gives me 4x minus 4x squared dx. And then I'm going to find the antiderivative to this. So this gives me the integral is going to be 4x squared over 2 minus 4x to the third over 3 from 0 to 1. So what I'm doing here is the antiderivative, which is now going to be 2x squared minus 4 over 3 x to the third from 0 to 1. Fundamental theorem says I plug in the top limits, so it's going to be 2 1 squared minus 4 over 3 1 to the third minus, and then when I plug in the bottom limit, since it's 0, it's not going to give me a value over here on this side. However, not all the time, not always you have the lower limit be equal to 0. So just don't assume that's always going to be 0. And then my answer is just whatever this simplifies to be. This simplifies to 2 minus 4 over 3, and which gives me, if I find the common denominator, 6 over 3 minus 4 over 3, which gives me a value of two curves. That's my answer. So the area between the curve is going to be 2 over 3. The area between the two curves is 2 over 3. Alright. Moving on to example number 2. Find the area bounded by this. Alright, in this case I don't have a graph given to me, but I first need to find the area bounded by the region. Well, the area bounded by this region is where the two curves intersect. And that's going to be true for most of these curves, is you want to find out where they intersect. So the way they intersect is where the two curves are equal to each other. So to find the boundary, to find your limits of integration, you have to figure out where they intersect. So you have to set them equal to each other. These are both set as y equals, so I have to set x squared minus 3 equal to 2x. And then I have to solve this. This is a quadratic, so I set it equal to 0, so I have to move this over. Okay, this is now factorable. This is going to be x minus 3, x plus 1 equal to 0. So I have x equal to 3, x equal to negative 1. So where they intersect are my limits of integration. So now I have to figure out which is the top and which is the bottom. Well, using a little bit of my thinking skill, I can, since I'm not given a graph, I can mentally provide a graph. This is going to be a parabola that opens up, and the y-intercept is at negative 3. So I can just kind of draw a parabola that looks like that. And this is going to be a straight line that has a slope of 2x. So it's going to go something like that. Right? And I can see that this straight line is going to be above the parabola. So my top function is going to be 2x, and then the bottom function is going to be x squared minus 3. And now I have my limits of integration, so I'll go ahead and set up my integral. So the area is going to equal the integral. Now I have to go from the smallest number, the lower limit, to the upper limit, the bigger number. So from negative 1 to 3. The top function is going to be 2x minus the bottom function, which is x squared minus 3 dx. And then simplifying this, I'm going to end up with 2x minus x squared plus 3 dx. This is my integral from negative 1 to 3. Now, I'm not going to sit here and integrate this term by term. I'm going to assume that you can find this integral by hand, or if you needed to, you can find this integral on your calculator. So I'm just going to have to take my word that the answer is 32 over 3, or if you found this on a calculator, it would be 10.667. So again, how I found this integral is based on something that I can already do by this point, which is find the integral by hand. Okay? Now, example number 3 is going to be a u-try. So even though it doesn't say u-try, I'm going to go ahead and write it right now. Alright, so find the area of the region bounded by the curves of this and this. And we'll go over this in class tomorrow. And well, here's what the region looks like. So what it's asking is to find the total region between the curves. So you're looking for this piece and this piece. So you guys can kind of think about that overnight, and we'll go over this tomorrow, how you would set up whenever you have multiple regions. And that's it for this video.